another series of mathematics 8th standard, but this would be part 3, more towards geometry like quadrilateral, practical geometry, and mensuration, mostly dealing with measurement of different shapes and all. So this would be quite different than the regular maths that we have done so far, but this is also necessary. So let's focus on this. Let's start on it with the slideshow. Play from chart. All right, this is let's start. Um, let's get to know the basics of what is quadrilaterals. So when it comes to here, we need to know basic things, okay? Basic definitions we got to aware of, or else it would be tough. For example, what is a plane curve? Joining a number of points without lifting the pencil from paper. That's the simplest way of representing it. So, a curve is somewhere like this. It is going maybe some shape, and it is just considering it as set of points which is connected without lifting the pencil from the paper. Just the simplest way of representing or defining a curve. Similarly, what is polygon? And that is the main topic under consideration in this chapter. Polygon, a closed curve made up of only line segments is called a polygon. So curve is kind of a just a free flow draw. It's not necessarily a line segment. So polygon, it's saying a closed curve made up only line segments. Examples: triangle with 3 sides, quadrilateral with 4 sides, pentagon with 5 sides, hexagon with 6 sides, hands on, henceforth. Next definition: what is a diagonal? So now we are referring quadrilaterals. We got to know what is a diagonal because it's part of it. So a line segment connecting two consecutive vertices is called a diagonal. Now let's try a little bit. Yeah. So this is primarily showing, yeah, what are the shapes of a polygon, quadrilateral like, and then next one, yeah. A line segment, when we are discussing diagonals, a line segment connecting two consecutive vertices here to here, it's called a diagonal. What is convex? Where all vertices are outward facing. So vertex is outward facing is called convex point. What is concave point? Where vertices are inward facing. This you can call it as concave point. Angle sum. This is a very interesting formula need to remember, and this is going to helpful for measuring various calculation of like what are the sum of all the angles of a quadrilateral or a polygon. So let's know this. Angle sum, total sum of angles. Example for a quadrilateral which can be two triangles. So for example, this is a quadrilateral. Now is a diagonal going. So you can literally say that okay, this is kind of a joining of two triangles, upper one, lower one. So now why this is mentioned here? So quadrilateral, what is the angle sum of a quadrilateral? Which is nothing but two triangles. A triangle has sum of 180 degrees, so a quadrilateral is 2 multiplied by 180 degree, that is 360 degree. Now let's continue more on the next would be how we are going to measure the angle sum formula. Formula for angle sum: if number of sides of a quadrilateral or a polygon is n, so here we are discussing about a polygon, not a quadrilateral. It's just polygon. Quadrilateral is also a polygon. So this is a brief description of what is angle sum for a polygon. If n is number of sides, then the angle sum is n minus 2 multiplied by 180. For say for a triangle where n is 3, it is 180. 3 minus 2 equal to 1, and then multiplied by 180 is 180. Where n is equal to 4, which is a quadrilateral, it would be kind of 180 multiplied by 2, that is 360. So this is the examples we are getting here. If n is equal to 5, this is the answer. And then, so that was the brief about angle sum. It's good to remember it, note it down, because it is going to help us during calculation of uh, angle sum in a polygon. Kind of quadrilaterals. So now let's just jump quickly to what are the kind of quadrilaterals. This is just basic of geometry that we are going to try in the next chapter. So these basics we need to remember, then only it is going to help us in following chapters. There are many types, but we will discuss a few below. So here we are going to discuss hardly 5 to 6 types, which are of primary importance when it comes to practical geometry in what you say in secondary medium. First one in this category is parallelogram. And then what is a parallelogram? Opposite sides are parallel, opposite sides are equal, opposite angles are equal, diagonals bisect each other. Now how you are going to pictorially define it, let's just get onto it. So this is a parallelogram, the upper half person. So it is saying opposite sides are parallel, that is true. Opposite sides are equal, this equal to this equal to this. Opposite angles are equal, this angle equal to this angle, this angle equal to this angle. Diagonals bisect each other, so these diagonals you see here bisect, that's why this part equal to this part, this part equal to this part. Now let's come to rhombus. What is a rhombus? Rhombus is a parallelogram with all sides equal. So this is a rhombus with is not but a parallelogram with all sides equal. So here we are seeing here it is just saying this side equal to this side, but effectively all sides are equal. It should be having double dots and all over. All the properties of parallelogram, whatever we discussed here, that is also applicable to here. And then diagonals will be perpendicular, which is already portrayed here. Rhombus is kind of perpendicular diagonals. Next one, what is a rectangle? Parallelogram with all right angles. All properties of parallelogram, all angles are right angles, equal diagonals. So that is a rectangle. Now this, let's just see what is a rectangle looks like. So this is a rectangle which is conforming to the upper 4 points, which is this is a parallelogram, all right angles and equal diagonals. Next one is a square. How does it look like? All sides equal, all the properties of parallelogram, rhombus and rectangle. So the equal sides 90 degrees here. By rhombus means perpendicular to each other, diagonals, and then bisect each other. Last in the series is a kite. This is very peculiar, so but it's better to know there are properties. Kite, a quadrilateral with two pairs of equal consecutive sides. Equal consecutive sides. These consecutive sides are equal. These consecutive sides are equal. Diagonals are perpendicular to each other. Longer diagonal is bisecting the shorter one. And here the another property is this angle equal to this angle, but this angle is not equal to this angle. So that's what the catch is. So B equal to D, but A is not equal to C. It's just a typical kite shape that you might have seen when you played with it. Next one. Now we are jumping to examples. How many diagonals a polygon has? Hmm. This is also an interesting formula, just like angle sum, where n is the number of sides, number of diagonals a polygon has is n multiplied by n minus 3 by 2. So for example, a hexagon is having n equal to 6, then the number of diagonals hexagon has is, we put this formula, it coming out to be 9. Now more examples will go. So here we're just matching sides we have, just revising more of what we have studied so far. A quadrilateral in which a pair of opposite sides are parallel. So which one from here? Here we are seeing it is A. Quadrilateral in which only a single pair of opposite sides are parallel, that is trapezium. Trapezium is a shape we didn't discuss here, maybe we'll discuss in following chapters and all. So where in trapezium you have only two parallel and then these are not parallel, and that's how it is. Number next, a quadrilateral having two pairs of equal adjacent sides but unequal opposite sides, that is coming out to be, we just studied that, equal two pairs of equal adjacent sides, two pairs of adjacent equal sides but not but unequal opposite sides, that is a kite, right? A quadrilateral having its opposite sides equal and angle measure 90 degree, which is nothing but a rectangle. Opposite sides are equal and the angle measure, interior angle measures are 90 degree. So it could qualify for square also, but in this case we need to see which one is most matching. So if square will be occupied by another option, then the leftover one we need to consider. So a quadrilateral having all sides equal, that is a square. So when you are solving a problem with matching sides, you need to see that you need to give some option to somebody, right? It shouldn't happen that one of the option 3 or option 3 you can mark both square and rectangle and leave option 4 or something like that. So we need to give, okay, 3 is also B is also, square is also qualifying for 3, rectangle is also qualifying for 3. So let's put rectangle, square also we can consider, but is there any other match for square? Yeah, number 4 is matching, so we need to do. It's little funny, but when these questions are coming in the exam, that's how you need to match it. You need to give something to one side, unless until it is saying match the following with multiple options. So next example, this is again one more thing. Match the following, it is saying number of sides in decagon, decagon means 10, number of sides 10. Diagonals are perpendicular, where the diagonals are perpendicular, let's say rhombus is the option, diagonals are perpendicular. Equal sides triangle, equilateral triangle, adjacent angles are supplementary, that is a parallelogram. So parallelogram, you will see a parallelogram here where the adjacent angles are supplement to each other because opposite sides are parallel. So one angle is 30 means the other one is 180 minus 30, that is called supplement. So other one will be 150. So that's how it is. So we already matched it, and then the next example, this is again matching table. So this is just, as I told you, this is just basic chapter before you're starting geometry and mensuration like measurement and all. So mostly theoretical it would be. So do not kind of go, I mean, don't see that this is theoretical, but that's how it is. Before going to the next chapter, you need to know the basics. Now coming here, we will see here This one, equal sides in a isosceles triangle. Isosceles triangle means two sides equal. So equal sides in isosceles triangle, that means is coming in the option 3 2. So there are two equal sides in an isosceles triangle. This one you may not have studied, but it's good to remember it. We will study more of it when you're doing practical geometry or in higher standards and all. We have also mensuration is coming, so different shapes are we going to study. But now just remember, a triangle with just two adjacent sides equal is called isosceles triangle. So A equal to option 3. Diagonals are congruent means diagonals are same. So here we need to see what is the minimum requirement here. uh, Diagonals are congruent same, we can give it to a rectangle or to a rhombus. But yeah, let's see if you're getting something else for rhombus. All sides in triangle are equal, that is equilateral triangle. All sides are congruent, it is not applicable for all, it is just applicable for rhombus. So we are giving rhombus D option. So then diagonals are congruent, we need to give it to rectangle. So that's how it is. So number C is going to, no, number B is going to 1, which is rectangle, and these ones we already discussed. Okay, this is again an interesting problem. Find the angle measure x in this figure. Is quite easy because you know this is one kind of trapezium. You see here, just two sides are parallel, but other two are not parallel. And we are just seeing here what would be the measure here. We know, so if it is parallel, we know these supplement each other. That's the quickest solution. But let's consider it is a quadrilateral and see how it is going to solve. All these four angle measures going to equal to 360. Now if you see that 360 and then 360 equal to so and then x equal to 16. So that's how we are calculating it. This is very tricky. If you don't know the theory, you cannot solve it. Among whatever all we discussed, this is the trickiest problem I can consider. How many sides does a regular polygon have if the measure of an exterior angle is 24? So when you say regular polygon, that means all the interior angles are equal. So that is the theory you need to understand. Regular polygon means all sides are equal, all the interior angles are equal. So he's saying exterior angle is 24 degree, then what are the number of sides? Now it's good to know. Regular polygon has n sides with all equal interior angles. So we need to just use the angle sum formula to calculate it. From angle sum formula, we can conclude that. So if the exterior angle is 24, then the interior angle is 180 minus 24, that is 156. So n multiplied by this 156 equal to n minus 2 multiplied by 180. This is the angle sum formula. So it is saying that okay, all interior angles are equal. So if n sides means n interior angles, n multiplied by 1 interior angle equal to, that's the whole angle sum. So this is the formula we are getting into, and then we solve, then we get n equal to 15. So it's saying that 15 sides of a regular polygon have the measure of exterior angle is 24. That's how it is. So if you don't remember this angle sum formula, it is tough to solve it. Okay, so that's about it for this chapter of quadrilaterals. So understanding quadrilaterals is the chapter, is chapter number 3. So we try to solve as many problems as we can, but rest all are kind of repetitive. But you need to solve all the problems from chapter 3. There will be exercise 1 2 3, just solve all of them to better understanding and remembering the content. So that's all for today, Fox, and then we will connect again in the next